Hey guys, a couple of weeks ago I was watching a video by Melinda Carr, which is someone I really like on YouTube. She does a lot of construction stuff. But she was doing a video on mushrooms or mycelium, which is really the roots of mushrooms, and how they were being used to they can essentially grow construction materials, packing materials, things like that. With mycelium. You should watch the video. I'll link it down below.
It is made up of two ingredients, mushrooms and hemp.
It's pretty cool, but it has to be in a really temperature and humidity controlled area, or the way that they grow these things. And that got me thinking and reminded me of someone that was asking me about making a using the ESP32 and the BME280 to make something to monitor his humidor, but it was too complicated for him, so he went another route. But then I was just thinking, hey, with all the stuff that we've done in the last year or so, we could put all that stuff together and come up with a whole IoT project. So it's going to be based around this amazing little thing right here. Actually, this is a carrier board. You can't even see the thing that's on there. Okay, it's the BME 280, which will measure temperature, pressure, and humidity, so we can make our little weather station like we did before. Now don't confuse that with the other, what is it, the BMP 280, which won't measure humidity. They have a little bit different shape. So this one, make sure, like if you're getting on eBay, you want to get the one that's kind of this square rather than the rectangular one, just to make sure you're getting the right stuff. Anyway, so we're going to use that cool little device, and I'm going to use, hold on, some in my pocket, aha, ESP32 Mini. This is the V2, which is probably what I'll use. I've been prototyping with the V1, but this is the V2. Don't forget, you can get these things on the store, right? They're pretty cool. This is the smallest prototype board that's out there, I think. But anyway, I'm going to use this. And then I just was down, I'm coming back from the shop, and I made this little case right here with a little, we can hang it up on something, just made it out of some plexiglass. So we're going to put all that stuff together. That'll be the device. And then we will connect this device. We'll make our measurements, and then we'll send the data up to Easy IoT. If you don't know about Easy IoT, see the link below and go watch the video on Easy IoT. And then that will put the data in the cloud. And then the last thing we'll do is a little app that we can use to pull the data down. I mean, using the Easy IoT SDK, but the development kit, software development kit, but we'll make a little app and we'll chart our stuff. So this will be a whole IoT project, from the device, making the measurements, pushing the data to the cloud up to Easy IoT, and then being able to pull the data down and do something with it. So it's a full IoT project. So let me get back up to the house and I'll start showing you all the things that we're going to do. Okay, one thing I forgot to say is that this project is something that you can do. You can get a BME 280, you can get an ESP32, and you can use my software and get this thing running, and then you can go from there. And it doesn't have to be one of my ESP32s. It can be I'm going to use a Mini, but you could use a fun board, or you can use any generic ESP32, and then you can get this going. You'll have yourself an IoT project, and then you can start modifying it from there, make it do exactly what you want. So this is a great place to start. And you just gotta love spring. This is my neighbor's dairy farm. Look how beautiful that is. Okay guys, let me show you the device setup. So this is what I've been programming or prototyping with. Okay, so I've got an ESP32 Mini right here. Now you don't have to use my stuff. I mean, you can use a fun board. All right, I got a lot of these left on the store, You can also use one of these generic devices that you get off of eBay. It doesn't come with this dude sitting on there, but so you can use one of these, anything that will run Python or MicroPython will work just fine. Okay, so the setup is really easy. So for me, I don't have a USB connector on this like you do on these things back here. I'm trying not to bang the camera, so I'm a little uncoordinated here. All right, these have USB, but I don't have USB, so this is my serial coming in, data. That's my return line. This is the ground, and then this is power coming in from my USB line, a USB to serial converter there. Okay, so that's all that is. So, you know, this, we can just ignore this for now. Okay. And then we got the device over here. Now, let's take a look at this device. All right, so that is the BME, the little can right there. Let's see if we can get it to, I'm not going to get it to focus and point at the same time. Oh, there we go. All right, so that can right there, that's the BME 280. And you'll notice that it is square. Okay, so that's different from the BMP. Well, anyway, I don't even know where one is. I had one. Oh, it's in my pocket still. All right, so this is the one you want to watch out for on eBay. You see how that can right there, it's kind of rectangular shaped, right? So you want to watch out for that on eBay because they'll tell you it's a BME, but it won't be. It'll be the BMP instead. Okay. All right. So this little guy, this is the carrier board that comes with it. It's the 3-volt carrier board. You don't want the 5-volt carrier board. You want the 3-volt carrier board. All right. And then you'll see that it has 5 connections. All right. So we've got the VCC, ground, the clock, the data, and then these last 2 are for SPI. All right, they're the clock select, the chip select and the data out. All right, we're not doing that. We're doing I2C instead. So we're only going to use these 4. We need power, we need ground, power's 3 volts, we need ground, we need clock, and we need data. That's the only 4 wires that we need. Okay, so let me plug this baby back in. There it is. All right, so that's what we have coming out of here right now. Here is our power. Here is our ground. And that's our clock. And that's our data. Now, we're doing something a little bit special because sometimes these things need to be reset. And they need a power reset. So instead of going straight to the 3 volts, or this is 5, but we can take 3 off of here if we wanted. But instead of going right to there and going right to ground, we're actually using some input-output pins. So we're using 2 input-output pins, and that way, if this thing gets jacked up, then we can turn the power off and do a full power on reset of this thing. Now, the reason we can do that on these IO pins is because this thing uses no power. All right, so you can pull 30 milliamps off, 30 milliamps off of these, no problem. But this is using like less than 1 or 2, or it's a tiny amount, so we don't have to worry about that. All right, so in this case, I think I've got. Hold on, I'm gonna mess up the camera. Yeah, I'm on. Let's see, I'm on 26, 25, 14, 13. All right, so this is 26. And 25. Now those are your standard I2C communication pins on the ESP32 for one of the I2C channels. So that's why we're using those. And then this is on 14 and this is on 13. So you'll see in the software that one of the things that we do is turn these pins on. So we change them from inputs to outputs. We set this one high and we set this one low, and that turns this thing right here on, and it allows us, so if something goes wrong and we recycle the whole thing, then we shut the power off, turn the power back on, and we get this thing set up fresh again. Okay, so that is the whole thing right there. The BME connect it with these 4 wires to these 4 pins, and then your standard ESP32 setup, however you accomplish that. Now, if you're unfamiliar with the ESP32 and programming it and MicroPython, I got a get started video, right? So go check out that get started video. I'll put a link down there, I guess. I'm gonna have a lot of links for this project. Okay, all right, that is the whole setup. Now, when we're done, I'm gonna use this, and then I'm gonna use this, and I'm gonna put this. I don't know. I hadn't even tried to see if this thing will fit. Oh no. Oh yeah, it'll fit. All right, just barely. It'll fit in there. So we're going to put that in there, and then I'm going to recycle the one from Ben's project. This is the old BME 280 that we had from Ben's project, and we'll put that on the, look at this. I already got some holes right here. We'll glue this baby on there, and then that'll fit on there. And then that'll be in there, and I got a little hole down here that we're going to run a power cord into that thing, and then we're just going to hang this on the wall outside. Okay, look at this. Last thing I was doing, I broke this thing. Last thing. Can you believe that? That pissed me off. I shouldn't say that. I was really put out. Anyway. That was the last thing, but it's not going to affect it. It's still going to be sealed up. I can still use the nuts and screw it, but anyway, that stuff happens. All right, that is the total physical setup that we got. So the next thing we're going to do is start looking at the software. So let's go do that. Okay, getting started. Now, this is my GitLab directory, and it is going to be exactly the same as if you went to Clayton's PCB shop on GitLab, right? So this stuff that we're looking at right here is exactly the same as this. So we're going into MicroPython, and then we're going into weather stations. And there's Ben's old weather station, which we have retired. And here's our new DIY IoT weather station. All right. Now there's 2 parts of it. The desktop part we'll get to in a minute. That's just a way demoing how we could look at the data. Just an example. And then this is what's going to happen. What's happening on the ESP32 that I'm using for prototyping this, and the one that I'm going to put into the case. Okay. All right. So here we go. Now, if you aren't, oh, you know what? I'd put that video of Beaker's web server. So that's what all that beeping is over there, is Beaker's web server beeping. Okay, anyway, if you're not familiar with MicroPython, then go and look at the video that I introduced, you know, how to put MicroPython on your ESP32 and all that. So check the links below in the description. Alright, so here's what it takes to run this. Now, it looks like a lot. Now, of course, replace, that's just how we're going to load the stuff up there. So that's not actually going on your device. Main is the script that brings everything together. Now, the other scripts that we're using are this one, we're running it with I2C, okay? So this is just a little library that hooks up and does the I2C. So we create an I2C bus, and that's what we use to connect to the BME 280. Okay, now here is the BME 280 library, and I will tell you right now, it's a bit tedious. So I have set it up. See, it says right there, it's set up for weather mode. Now this is an amazing little chip. I mean, I use it for a drone, and you can actually measure the distance by raising and lowering it, you know, a half a meter. You can detect that, and the drone can, you know that it's changing altitude. They're very sensitive, but it's not set up that way. This is set up for weather, which is a lot simpler. Okay, so there's a lot of stuff. You can read all this stuff, but the main thing, after we set it up, we're just going to be calling the get data, or we're not actually going to call that. we're going to call this weather function. So we have a weather function that gives you European weather. If you want American weather, you have to use the US function, right? So we do our weather a little differently here. We do inches of mercury instead of millibars, and stuff like that. Okay, so anyway, this is a tedious library. Look at all this math. This is for converting the raw values, so there's all kind of stuff. Enjoy it if you want to look through there, go for it, but we won't worry about that now. Okay, so that's the sensor BME, and then the last thing we'll use is this Easy IoT, and this is a special version of Easy IoT that is just for MicroPython. It's a little bit smaller, so we'll be using the post data, and then later on in the desktop we'll be using the get data. But that's all that we're going to do is post data and get data. Now, if you're unfamiliar with Easy IoT, it's just a simple application for you to write data to the web and get it back down again. So there's a video for that. I'll put the link below. Okay, so those are the supplemental programs, or the extra programs, the library that we're going to use. The I2C Bus to run the BME, and then we're going to push it to Easy IoT. That's our cloud location. Alright, so the thing that we need to know then is about Maine, and that's where we do all of the good stuff, is right here in Maine. Okay, so when you pop open your Maine, once you download this stuff, then you're going to have to put in a Wi-Fi ESSID and password so that the ESP32 can connect to your Wi-Fi location. Alright, and then you should have a key and a secret that you'll get from Easy IoT. I'm using the example key and secret so everybody can take a look at it. And then you have to say, what group and what device you're going to use for Easy IoT, because the fields on Easy IoT are a group, device, and then you got your 4 data fields, right? So we're just going to say this is the weather group and Clayton 1. So when we look at the data, let me see if we can look at the data right quick. Yeah. So if we look at some Easy IoT data, this is where we see that I've been posting stuff up there, right? So that is the group, and that is the device, and then I'm putting 3 pieces of data. I'm not putting anything in the last piece of data. Okay, so in Maine, you want to go ahead and put your, it doesn't matter what it is. I mean, there's limitations. You'll see when you work with the Easy IoT and watch the Easy IoT video. There's limitations to length, but you put that stuff in there. Okay, now we are using the I2C. The clock is on 25, pin 25, and the data is on pin 26, and this is the frequency that we're running at. Now you can change this if you like, but this is the one of the hardware I2C channels, so that's why we're using it. Now the BME, remember I was saying that we had a positive and negative pin that we're actually using. So the negative pin is pin 13, the positive pin is pin 14. If you use different pins, make sure they're output pins, and then you can change these numbers to match. The BME address by default is 118 on the I2C bus. There's another option, but you're probably not going to use that. Okay, set your local altitude. When you are talking about barometric pressure, you have to adjust it to your altitude above sea level. Okay, so this is in meters. So this is me. I'm roughly 222 meters above sea level. Okay, BME weather, I'm doing it in US, right, because I want it in inches of mercury instead of millibars. And I want it in Fahrenheit instead of Celsius. But if you're not in the United States, you're probably going to want to set this to false. Okay? All right, those are the variables that you have to set. And then we just go into the program itself. Okay, so here's our basic imports. These are MicroPython imports. These are our libraries. So here's our I2C Bus library, here's our BME library, and here's our Easy IoT mini library. Okay, and then we have one main loop right here. Okay, let's see. Okay, so we have this big loop. You know, this is our main function. We have this big loop, and it has a catch down here, and if it messes up, then it sleeps for 10 seconds and tries to do it again. So that would be on a major error, and the reason what that does is it's going to reset up the Wi-Fi, reset up Easy IoT. It's going to cycle the BME 280's power and set up the I2C bus again, and then go into the inner loop or the minor loop. Okay, so that's our major loop, and our catch is here. So if anything goes wrong, it goes through and starts everything up correctly. Okay, so here's what happens. We set up the Wi-Fi, so Easy IoT does a scan. It prints out all the available Wi-Fi, and then it uses your Wi-Fi and your ESSID and password to set it up. So it's this stuff right here. Okay, and it connects to your network. The next thing we do is we set the Easy IoT key and secret. You should be using your own. If you use the example one, that's okay, but everybody's going to be using the example one. I use the example one for example stuff, and it'll just get pushed out of there really quick, so your data's not going to last very long. If you're using your own, then you can have up to 1024 lines of data in there at a time. Okay. All right, now here's where we're cycling the power on the BME 280. So we're making both those pins inputs, which turns them off. We give it a little bit of time to stabilize, and then we're making the pins outputs, and this pin we make it negative, and this pin we make it positive, and that turns it on, and then we sleep a little bit to give it time for everything to stabilize. So that is our hard reset on the BME 280. All right, then we're going to set up the I2C bus, just using the variables that we have up here. These variables right there. So that sets up the I2C bus. We do it. I have it. You don't have to do this, but it does a scan and will print out the address, right, and tell you how many devices it found on the I2C bus. Should only be one, right, because we only just have one on there. All right, and then we set up the BME. So we tell it what the bus is, or we give it the bus that we've already instantiated. We tell it what address we're working on, and we give it our altitude so that it can calculate stuff correctly. And we don't need to do this zero feature. That's for if you're using it for drones and stuff like that. Okay, so now at this point everything is set up, and now we go into a secondary loop where we're reading the data, pushing it to Easy IoT, going to sleep for a while. Okay, so I've got it printing a bunch of stuff just so we can see it, but what we're counting how many loops we've done. Now this is where we get the data from the BME 280, and this is something that the way we have it set up, you got to call this and it wakes up the BME 280, it makes it do a conversion, get the data ready, and then after we do that, then we can read the data. So if you set it up for weather or for US, then it's going to use this function, and if you haven't, then it's going to use this, and it'll return it in metric units. Then it'll print that data, and then it will, just with this one line, it's posting it up to Easy IoT. So it's using the group and all that, and then we're doing temperature, pressure, and humidity as the first three pieces of data. Okay, and then we are printing that, yeah, we pushed it up there to Easy IoT. And then in this case, we're sleeping for 10 minutes, okay, because you don't need to update your weather constantly. If you do it too much, you'll get booted off Easy IoT. But let's say for demo, we'll go to every 4 seconds instead of 10 minutes. So I'll just mod this just for a minute. Okay, so we modded that. And that's it. That's all that we're doing. So we're waking up the device, reading the data, posting to Easy IoT, and then waiting for a while. Now, if you're on super low power, you might want to put in a deep sleep here, but for demonstration, I'm not bothering with that. Okay, and there's our catch things, and that's it. Okay, so I guess we should. Well, let's just, okay, so I'm doing a Control C. I'm in Picocom connected to my device. So I'm going to do a Control AX, and that gets us out of there. And then we're going to use, okay, so we're using the Repelays program. This is our port. I'm on Linux, so I'm in dev TTY USB 2. And what we're going to do is, instead of these things that I have that I was doing specifically, we're going to do an A, and that's just going to load everything up on there. Okay, so we're loading all of our programs. Now remember, we changed this. You shouldn't be doing it every 4 seconds, but that's what we changed to. Okay, now if this stuff doesn't look familiar to you, like using Picocom and these other things, there's other ways that you can do it. But if you check out my intro video or tutorial for the ESP32, then this will all become familiar. Alright, so I'm using Picocom to connect to my device. Alright, we're ready, and I'm going to do a Control D, which is a hard reboot, and let's just see what happens. Alright, so it booted, and not really. Okay, so we already did it. Alright, so let's look at what's happening. So we loaded Maine, we loaded the I2C Bus, we loaded the BME280. This is Easy IoT. And then we're printing out all the networks that are around here, and then we're connecting to our network. And then, yes, I have a special network for testing that's called your ESSID. Clever, isn't it? Alright, anyway, so then it's checking the I2C, and it says, yep, there's 118, and that's the default address on the I2C bus for the BME280. They all have that as their default. Okay, and then we're checking, it checks out, the BME is online, the BME is ready, and then here's our loops. So loop 1, here's the data that we got. We loaded it to IoT, and we sleep for 10 minutes. Not really, we're only for 4 seconds, and then we're going back. So this is the temperature. Of course, this is sitting on my desk, so it's indoor temperature. But here's the temperature. This is the barometric pressure. It's been like that for days now. And then here is the relative humidity, which that's pretty low for here. So there we go. All right, so now we're going through our loops, and that's about it. This thing is up and running. So really all you got to do now is get it in a case, and you know, you got to have the BME on the outside of the case and the other parts on the inside of the case, and then put it in a place where you can have power. Alright, so that is pretty much it for the ESP32 side. So let's run over to the desktop and see what's happening there. Alright, before we look at data, we got to make some real data, okay? So here's the case. Turned out okay if I hadn't broke it, but everything else turned out okay. Okay, there's the BME 280 inside there. This piece was from Ben's old weather station. And then here's the ESP Mini in there. And I just have a USB power thing there. I'm going to plug it in right here just so we can collect some data. So I'm going to hang it up right here. My wife will not like that, but this is for science. So, all right, let's see. Plug it in. Green light comes on. All right, we should get a blue here in a second after it. Okay, now we're connected to the internet. We're getting data going. Okay, it sent it to Easy IoT, and then it should start flashing. Yeah, now it's in its sleep cycle. Okay, so we're going to let this collect data for a little while. Then we'll look at it. Now we've had about, well, almost 24 hours, minus a few, because I didn't get this thing started till after dark, but we've had about 24 hours of this thing going. So let's go and look at some data on Easy IoT. Okay, now we're going to do the desktop part, which is it's kind of the third part of the project. Okay, so we started out by putting our device together, prototyping it, getting it programmed, get everything working the way that we wanted to, and then we put it in a case, we put it outside, we started collecting real data and pushing that data up to the cloud. And the last thing that we want to do is actually use that data. So we're going to pull it down, or we're going to look at it, we're going to pull it down, we'll put it in a little plot, but I mean, there's whatever you want to do with it. We'll put it in a little plot, and that'll be the third part of the project. So this is a whole IoT project, from prototyping, getting it running, putting data up in the cloud, bringing data down. Okay? So let's get into the desktop apps. Now, these are really simplified, and to start out with, let me just delete these right quick. We'll make new ones in just a second. All right, so these are just some simplified apps to kind of show you what's going on. Now, this is Easy IoT. This is the SDK that comes with Easy IoT, and it's got all the functions that we need for, you know, posting data, watching our data grow, reading our data, getting our data, and that's what we use to interact with IoT, or Easy IoT, whether we're on the desktop or whether we're on the ESP32. Either way, okay, we can use this library. And then this is a little charting library that I've been fooling around trying to write, and it makes charts in uses SVG to make charts. And I was going to add it to the ESP32 server, but I haven't gotten it going yet. I mean, it works, but I'm not all the way done with it. So anyway, we're just going to use that as a little plotter to draw some charts. Okay, and then our main thing is this right here, which is just our little weather plot. Well, first thing, why don't we just from the command line, we can start Python. Now this is not MicroPython, this is, you know, real Python. And then we'll import Easy IoT, and then we can just do, for a simple way to do it is just we can get data. We'll do that. Let's see if I can remember. We'll get, I don't know, let's get 10 lines of data. And we're just getting, okay, let me see. it gave it to us all at once. We just need to do this. There we go. Okay, so these were the last lines of data. So you can see that the only person that's using the example account, which is what happens when you don't sign in and give it credentials, is me right now. And the new device, we call it Clayton 2. Clayton 1 was the prototype. The one that's actually outside is Clayton 2. And it's been posting data for almost 24 hours. So we'll be able to look at some nice charts. But this is the data that's up there, and we're just pulling it down. So this is exactly what we'll do in the chart script here in just a minute. Okay, so let's get out of Python there. And let's open up the little chart script that I have right here. So this is nothing fancy. I'm just demonstrating what can be done. So here's our imports. Web browser will just throw the charts up into a web browser. Start them in a web browser. So we're importing Easy IoT, and we're importing microchart. Now for Easy IoT, we have to put in our credentials. In this case, we're using example as the example account. And let's see, we need to put in our group, because what we really want to do is select. I don't want to select, maybe I'm putting up data for a lot of devices and different groups, and it's all going up there, and I want to just select a certain type of data, not just everything like we did here. So we'll specify to use the group weather and Clayton 2. Alright, and then here's just the name of the file that we'll create. Okay, so what are we doing? We're setting our key and secret right here, and then right here we are getting our data. We're telling it to get 1024, or basically as much as you can, and we're telling it that this is the group we should use, the one we set right here, and this is the device that we should use, the one we set right here. Okay, and then we're getting the data, we're sorting the data, and then we're going to, we'll just print it. You don't really need to do that, but we can print it just so we can see it, and then we'll tell how many rows it is. And then here's where we're going through a format. We're splitting it up into temperature data, pressure data, humidity data, and we're making some labels that we want to use in our chart. And then this is where we make the plot, give it our titles and all that sort of thing. And then we'll tell it to open in the web browser. And then pressure data doesn't change a lot. So in order to see it actually changing, I went ahead and made a second plot just using the pressure data right there. Okay, and then we'll open that in the web browser as well. And that's it. Okay, that's all that this thing does. So it's going to Easy IoT, it's collecting our most recent data, and it's going to make a chart out of it. So I'm just going to run this, and there it goes. All right, let's get back here for a second and see what it did. So this is the data. This is the stuff it pulled down. Said it pulled 128 rows. I might have a limit on the example account of how many rows you can pull. But anyway, it pulled 128 rows, and then it plotted it. So let's take a look. So we'll start here. All right. So this is in GMT, day and the hour. So this was last night when I put the thing outside. So you can see it was already late, getting into the evening, and the temperature was already down to 55. That's Fahrenheit. Okay, so the temperature was down, the relative humidity was up, because when your temperature goes down, relative humidity goes up. All right, and then during the day, it went up and it got, over, wow, I didn't realize it got that hot. Okay, so it's kind of a nice balmy spring day there, in the high 70s. All right, and of course, as it heats up, the relative humidity goes down, and then we've dropped back down, so we're around 60 degrees outside right now. And of course, the humidity's up. Now, this green line is the pressure, and see, you can't, compared to these others, you can't see it changing. So I plotted it by itself, and then here's the change. So this was, you know, well, it was kind of up and then down and back up today. I don't understand pressure exactly, but in terms of how it works with the weather. But that's it. Okay, so this is what IoT does. This is what it's for. It's for collecting data and sending it to the cloud. Now, there's one piece of IoT that we didn't cover, and that would be going in the opposite direction, like sending a command out. But if you read the Easy IoT instructions in GitLab, then you will see how to do that as well. So that's it. That is our IoT project altogether.
Mushrooms and hemp.